All right, good day. Hope that you're doing well. So in this question, we're going to be starting with analytical geometry exam questions from the November 2023 paper, right? So now they're saying the diagram below, triangle RPQ is drawn, right? So basically, this is the big triangle, and they're given us the coordinates P as well as Q. Now, M is the midpoint, and they gave us the coordinate of the midpoint of line RQ. Now, determine the gradient of MQ, right? So now, how would I go about determining the gradient of MQ? Okay, I have my values at M, or my coordinates at M, as well as my coordinates at Q. I can make use of my gradient formula. So I could just say y at M minus my y at Q all over my x at M minus my x at Q. All right. Now, what is my y at M? My y at M is 0 minus my y at Q, which is -2, all divided by my x at M, which is -2, minus my x at Q, which is 4. So as a result, this is the same as 2 divided by -6. And the gradient of MQ in this instance is going to be equals to -1/3. Now moving on to the next equation. Now moving on to the next question, we need to determine the equation of MP in a form of y is equals to mx plus c. I'm going to try and determine, so remember, these two lines are parallel, perpendicular to one another. So MP is perpendicular to MQ. Now remember, what do we know about perpendicular lines? If I take the gradient of MQ and I multiply it with the gradient of MP, I expect to get -1. This is what we know so far about perpendicular lines. Now, I have my gradient of MQ, which is -1/3, multiplied by the gradient of MP. This is going to be equals to -1. Now, as a result, to get the gradient of MP, I'm going to divide both sides by -1/3. So basically, this would be -1 divided by -1/3. And punching this into my calculator, the gradient of MP should be equals to 3. Right? Now, I have the gradient of MP as 3. Now, remember, this should be in the form of y is equals to mx plus c. I've determined my m as 3. Now, to determine the full equation, I can substitute any value on my MP line, right? Or any coordinates. I'm just going to substitute the coordinates at P, right? My y at P is 6. As a result, the y-intercept, which is my value of c, is going to be equals to 6, right? Remember, also your c represents the y-intercept of your line. In this case, we're given the y-intercept is 6. So basically, the equation of MP is 3x plus 6, right? Now, coordinates of R. Now, we have, remember, we have the midpoint of RQ line, right? And its midpoint is at point M. So we can make use of the midpoint formula to determine the coordinates at R. Now, remember, how did they go about finding these coordinates at M? It was, I'm going to write down the equation here. So if you take x at R plus x at Q divided by 2, you're going to get the x value of your midpoint. And if you take your y at R plus your y at Q divided by 2, you're going to get the y value of your midpoint, right? So now I'm going to start with my x value of my midpoint. So my x value of my midpoint in this instance is -2. Now substituting x at R, I'm looking for my coordinates at R, so this would be x at R plus my x at Q is 4, and this divided by 2. Now for my y value at R, I'm also going to do the same, right? So the y value of my midpoint is 0, and to get that, they had to take my y at R, add it to my y at Q, right, which is -2, and divide everything by 2. Now, solving for my x at R, this here, I'm going to multiply both sides by 2 to get rid of this 2. So basically, on the other side, I would have -4 is equals to x at R plus 4. Now, taking the 4 to the other side is going to become a minus, and -4 minus 4, my x at R, it will be -8. Now, what about my y at R? Doing my workings on the other side, multiplying both sides by 2, this is still going to remain as 0. Y at R -2. And taking the 2 to the other side, my y at R is going to be equals to +2. So basically, the coordinates of my R, or my point R, is -8 and 2. Now, I need to determine my length from P to Q, and I'm going to make use of my distance formula, right? So remember my distance formula. In this case, I'm trying to determine the length from P to Q. So going to my formula sheet, this is my distance formula, right? X2 minus x1 squared plus y2 minus y1 squared, right? So now substituting my coordinates, my x2, I'm going to make it my q, basically. My x at q, it's 4, minus my x at p, which is 0 squared, plus my y at q is minus 2, minus my y at p, which is 6. And punching this into my calculator, the distance from p to q in its simplest set form, it will be equals to 4 root 5. This would be my final answer. Now, given that RPQT is a parallelogram, right? So let me try and highlight the parallelogram that they're talking about. So it's RPQ, and they're telling me that T is going to be on the third quadrant, meaning that T to be somewhere here. So this is my third quadrant. This is where I expect my T to be. Determine the coordinates of T if point T is in the third quadrant. Now, how will I go about determining my coordinates at T? Now, remember, with regards to parallelograms, right, if I were to draw this here, what are the properties of your parallelogram that you know? Is that these are parallel to one another, and also these opposite lines, they are equal to one another. Same applies to these. They are parallel to one another, and these are going to be equal to one another. Now, I know that diagonals of my parallelogram, they bisect one another. Basically, this here is going to be equal to that here, right? This is also the information that I know about my diagonals. So as a result, my M is going to be the midpoint of this line from P to T. Now, if M is the midpoint, I can use the same technique that I used to calculate my coordinates at R to find my coordinates at T. Basically, x at T plus x at P all over 2 is going to be the x coordinate at my midpoint, which is minus 2. Now, same applies to my y. My y at t plus my y at p all over 2 is going to be equals to the midpoint y value, which is 0. Now, substituting values here on my x's. What is my x at t? This is what I'm trying to determine. So I'm going to write it as x at t. So x at t plus my x at p. My x at p is 0 all over 2. This is equals to negative 2. So first I'm going to get rid of this 2 by multiplying it on both sides, so that x at t is going to be equals to negative 4. So I know that the x value at this t is going to be equals to negative 4. Now, how would I find my corresponding y value? I'm going to use the same approach. What is my y at t? Y at t is what I'm trying to determine, plus my y at p, it's 6. This is equals to 0. Now, multiplying 2 on both sides, so y at t plus 6 is going to be equals to 0, and my y at t is going to be equals to negative 6. This here would be minus 6. And this would be my final answer. Now, explain why RPQT, so RPQT, basically this shape, it's a rhombus. Now, remember, your rhombus, they intersect at 90 degrees, right? So basically these diagonals, they intersect at 90 degrees. So this could be your main reason that you would explain, because if this, right? So basically my reason here to be the diagonals of a rhombus, they intersect, right? So basically they intersect at 90 degrees. As you could see, these diagonals, they meet at 90 degrees. Hence, the shape, it will be that of a rhombus. And that will be all for this question. In the next question, we're going to be continuing with question 4, which is still an analytical geometry exam question. So make sure you stay tuned. Thanks.